Look up at the night sky on a dead, moonless night. The stars seem suspended just out of our grasp, like the glowing windows of an unreachable metropolis seen across a black, frozen ocean. We point out the brightest among them, we map their constellations, and we assign them names that imply a comforting sense of proximity. Our closest stellar neighbor, Proxima Centauri. The very prefix suggests an intimacy, an impending encounter. It implies a threshold we are inevitably destined to cross. We carelessly throw around the measurement of 4.24 light-years as if it were a simple highway exit sign on the cosmic interstate. It sounds manageable. It feels like a mere stepping stone for a species that learned to split the atom and leave its footprints in the lunar dust. But the human mind is fundamentally unequipped to comprehend the violent, crushing reality of that distance. We are confined within a neurological cage, wired by terrestrial evolution, to measure space in days of walking or hours of flying. We look at the nearest star and see a destination. The universe looks at us and sees a species under strict quarantine. Consider the fastest machine ever constructed by human hands, a probe carving through the absolute vacuum at a velocity that would span a terrestrial ocean in a fraction of a heartbeat. Now point that pinnacle of our engineering toward our so-called neighbor. The engineers who drafted its blueprints will die. Their children will die. Empires will rise and collapse. Our continents will drift. Our oceans may boil. And that probe will still be plunging through an endless silent void, bathed in nothing but lethal stellar radiation. For tens of thousands of years, it will remain entirely alone, moving through a darkness so absolute, it defies the very concept of travel. The void between our solar system and the next is not an empty road waiting for our ships. It is a thermodynamic fortress. It is a physical, mathematical barrier enforced by the cold mechanics of reality, designed to ensure that the inhabitants of this microscopic grain of rock stay exactly where they were born. The light you see from Proxima Centauri tonight is tired, ancient radiation. It has spent years crossing an abyss so terrifyingly vast that the raw numbers required to map it cease to look like physics and begin to look like a permanent exile. If you are willing to abandon the comforting illusions we tell ourselves about conquering the galaxy, if you seek to understand the brutal, uncompromising machinery of the cosmos, subscribe and join us on this descent. We are going to break down the sheer, terrifying scale of the abyss and uncover why the closest star in the heavens is a completely impenetrable wall. To understand why we are trapped, we first have to dissect the flawed machinery of our own perception. Human intuition is a terrestrial survival tool forged over millions of years on the savannas of a tiny, rocky sphere. Our brains were optimized to calculate the trajectory of a thrown spear, the distance to the nearest water source, or the time it would take to outrun a predator before nightfall. We measure reality in strides, in heartbeats, in the arc of the sun across a familiar sky. The horizon was the absolute boundary of our ancestral world. Anything beyond that curved line of Earth was an abstraction, a myth. And so when our ancestors looked upward into the suffocating darkness of the night, they did what the human mind always does when faced with the incomprehensible. They shrank it. They domesticated the infinite. For millennia, the greatest minds of our species believed the universe was a finite, comforting architecture. The ancient Greeks, observing the pristine mathematical rotation of the night sky, envisioned the stars as glowing pinpricks on the inside of a massive, solid sphere of crystal. This celestial sphere rotated slowly, eternally, just beyond the orbit of Saturn. It was an elegant mechanical universe, like the internal gears of a flawless brass clockwork. The stars were our ceiling. They were part of our neighborhood. If you could somehow build a tower high enough, or construct wings strong enough, you could reach out and touch the crystalline boundary of creation. It was a universe built to the scale of human ego. It placed us securely at the center of a cosmic snow globe, safe, observed, and entirely self-contained. But this comforting illusion was destined to shatter, and the instrument of its destruction was not a telescope, but a simple geometric concept: parallax. The mechanism of parallax is something you experience every waking moment. If you hold your finger in front of your face and close one eye, then the other, your finger appears to jump back and forth against the background. The closer the object, the more violent the shift. The further away, the smaller the jump. When humanity finally accepted that the Earth was not stationary, but was instead plunging through space, orbiting the Sun in a massive ellipse, a terrifying logical consequence emerged. If the Earth is moving from one side of the Sun to the other over the course of 6 months, our vantage point in the universe shifts by nearly 200 million miles. Therefore, like the finger held in front of a shifting eye, the closest stars should visibly sway back and forth against the deeper background stars. Yet, when the early astronomers trained their rudimentary lenses on the night sky, straining their eyes in freezing observatories, searching for this geometric proof of a moving Earth, they saw nothing. The stars remained utterly, defiantly fixed. Not a single point of light shifted by even the width of a human hair. This absence of movement presented a horrifying dilemma. Either the Earth was completely stationary, trapped forever at the center of the universe, or the stars were pushed so impossibly far away that their parallax shift was too microscopic for the human eye to perceive. To accept the moving Earth was to accept an abyss. The mathematics demanded that the universe was not a snug, crystalline sphere, but a terrifying, gaping void. For generations, this mathematical silence haunted astronomers. They knew the abyss was there, lurking in the numbers, but they lacked the optical machinery to measure it. The universe was hiding its true scale behind the limitations of ground glass and brass tubes. It was not until the year 1838 that the cognitive cage was permanently broken. A German astronomer named Friedrich Bessel, working with a specially designed telescope, focused his relentless attention on an obscure, dim star known as 61 Cygni. Night after cold night, he measured its position with a manic, obsessive precision. And finally, after centuries of failure, the universe yielded its first terrifying measurement. Bessel detected the parallax shift. It was a movement so infinitesimally small that it was akin to measuring the width of a coin from miles away through a thick fog. When Bessel translated that microscopic angular shift into actual distance, the crystalline canopy of the ancients shattered forever. 61 Cygni was not millions of miles away. It was not billions of miles away. The numbers were so absurd, so grotesque in their magnitude, that they broke the very language of distance. Miles and kilometers became entirely useless, reduced to rounding errors in the face of such a void. A new metric had to be weaponized to express the nightmare, the light year. But the term light year is a linguistic trap. It sounds like a measure of time, a calendar of cosmic events. It is in fact a measurement of pure physical limitation. Light is the absolute speed limit of causality in our universe. It is the fastest speed at which any piece of information, any force, any structure of matter can propagate through the vacuum. It travels at roughly 186,000 miles per second. At that speed, a beam of light could wrap around the equator of the Earth 7 times in a single second. It takes roughly 8 minutes for light to bridge the 93 million miles between the Sun and the Earth. When we say a star is 4 light years away, our terrestrial brains fail to grasp the horror of that statement. We imagine a fast ship, but think of it not as a distance, but as the latency of reality itself. Imagine the entire global internet infrastructure. When you send a message to the other side of the planet, the delay is measured in milliseconds. The servers communicate almost instantaneously. Now imagine a server so isolated, so completely cut off from the network, that a signal traveling at the absolute maximum speed the laws of physics allow takes 4 entire years just to arrive, and 4 more years to receive a confirmation of receipt. Proxima Centauri, our so-called neighbor, is sitting out there at a distance of 4.24 light years. To translate that into the terrestrial miles, our brains are wired to understand. It is roughly 25 trillion miles away. 25 trillion. The human brain simply discards the word trillion. We lump it in with billion and million as just another word for a very large amount. But let us break down the brutal mechanics of that number. If you were to shrink the sun down to the size of a standard marble and place it in the center of a large city, the Earth would be a microscopic speck of dust orbiting just a few feet away. Pluto, the frozen edge of our classical solar system, would be a grain of sand a few city blocks distant. On this exact same scale, where our entire solar system fits comfortably within a single neighborhood, where do you think you would have to walk to place the marble representing Proxima Centauri? Not the next town over, not the next state. You would have to walk across entire continents. From the Sun Marble in New York, you would have to travel all the way to Los Angeles just to find the very next star. And between that marble in New York and the marble in California, there is nothing. No air, no light, no warmth. Only a lethal, freezing vacuum stretching out in a permanent, silent night. This is the architecture of our isolation. We have spent decades throwing our finest robotic emissaries into the dark. The Voyager 1 spacecraft, launched in the 1970s, is the most distant human-made object in existence. It has been tearing away from the sun at over 38,000 miles per hour day and night for nearly half a century. It has crossed the heliopause, the magnetic bubble generated by our sun, and has finally tasted the bitter, raw radiation of interstellar space. It is a triumph of engineering, a testament to human curiosity. Yet if Voyager 1 were aimed directly at Proxima Centauri, which it is not, it would take it over 70,000 years to cross the chasm. 70,000 years of silent, powerless drifting. All of recorded human history, from the first fires in the caves to the detonation of the atomic bomb, is a fleeting, insignificant spark compared to the time it takes our fastest machine to cross the street to our closest neighbor. Our intuition lies to us. It tells us that because we can see the light of these stars, they are participants in our reality. But the light hitting your retina when you look through a telescope is an artifact, a ghost. The photons from Proxima Centauri striking the Earth right now began their journey years ago. If Proxima Centauri were to explode into a blinding supernova tonight, we would continue to look at a calm, peaceful red dot in the sky for over 4 years. The universe operates on a delay so massive that we are completely severed from the present moment of anything beyond our immediate orbit. We are living in a temporal quarantine, surrounded by an ocean of dead space that acts as an insurmountable moat. We have mapped the shoreline of our tiny island. We have waded into the shallow waters and looked out at the glowing beacons across the dark water. But the deeper we look into the mechanics of that void, the more we realize the water is not meant to be sailed. The emptiness is not merely an absence of matter. It is a physical entity, an expanse of nothingness so vast and so aggressive that it swallows light, time, and human ambition without leaving a ripple. And as we begin to analyze the actual physics of crossing that ocean, as we calculate the energy required to force a ship through that specific, merciless environment, the numbers stop looking like engineering challenges. The numbers stop looking like engineering challenges and begin to resemble a quarantine order. To understand the barrier, we must first look at the texture of the emptiness itself. The colloquial phrase, the vacuum of space, is a dangerous oversimplification. Space is not completely empty. It is a highly attenuated, freezing medium, a soup of primordial gas, microscopic dust grains, and lethal cosmic rays. In the space between stars, the interstellar medium, you might find only a single atom of hydrogen per cubic centimeter. By terrestrial standards, this is a vacuum far more perfect than any artificial chamber we can construct in our most advanced laboratories. It feels like nothing. It looks like nothing. But at the speeds required to cross the interstellar abyss in a human lifetime, this nothing transforms into a physical wall of kinetic devastation. Let us translate the cold mathematics of kinetic energy into a physical reality. The energy of an object in motion is tied directly to the square of its velocity. If you double your speed, the destructive energy does not double, it quadruples. If you want to reach Proxima Centauri in 40 years, you need to travel at roughly 10% the speed of light. That is over 18 million miles per hour. At that velocity, the gentle, invisible atoms of the interstellar medium become a relentless barrage of high-energy radiation. The friction of striking single hydrogen atoms at a fraction of light speed would superheat the hull of any spacecraft, generating a bow shock of lethal X-rays. But the individual atoms are the least of your concerns. Imagine a single grain of interstellar dust, a fragment of silicate or carbon no larger than a grain of sand, suspended silently in the dark. If a spacecraft moving at 10% the speed of light strikes that microscopic grain, The mathematical equation governing kinetic energy dictates an impact equivalent to the detonation of hundreds of pounds of high explosives. Now, extrapolate that across a journey of 25 trillion miles. The void is a minefield. To travel fast enough to cheat the clock of human mortality is to turn the very fabric of space into an abrasive, explosive gauntlet that will slowly, methodically tear any physical structure to atomic shreds. And what awaits us at the end of this apocalyptic gauntlet? Our instinct is to imagine a welcoming sun, a golden star warming a new Earth. But Proxima Centauri is not like our sun. It is a red dwarf, a main sequence star of the spectral type M. It is small, containing barely 12% of the mass of our own sun, and it is incredibly dense. If you could place it side by side with the planet Jupiter, the star would be only marginally larger in physical diameter, yet it burns with a gravitational fury that crushes its hydrogen core into nuclear fusion. It emits a fraction of a percent of our sun's luminosity, glowing with a dim, sickly infrared light. To human eyes, if you were orbiting it, it would not be blinding white but a deep, bruised magenta. But do not let its small stature deceive you. The physics of a red dwarf make it an incredibly violent, unstable neighbor. Unlike our sun, which has distinct internal layers that regulate its energy output, a star as small as Proxima is entirely convective. The superheated plasma of its core boils constantly all the way to its surface, like water in a kettle. This relentless churning convection generates magnetic fields that are twisted, snapped, and reconnected with terrifying force. When these magnetic field lines inevitably snap, they release catastrophic amounts of stored energy. Astronomers call them stellar flares, but the term fails to capture the scale of the violence. A flare from Proxima Centauri can increase the star's brightness by thousands of times in a matter of seconds. It unleashes a tsunami of sterilizing ultraviolet and X-ray radiation into the surrounding space. We have observed flares from this tiny star that are 10 times more powerful than the largest solar flares ever recorded in our own system. If you were standing on a planet orbiting this star, the sky would periodically erupt into a blinding, lethal flash, stripping away the atmosphere and bombarding the surface with enough radiation to shatter complex molecular bonds. This is the entity we call our closest neighbor, a churning, hyperactive reactor, violently lashing out in the dark. Yet, despite the dimness of the star and the crushing distance, we know intimate, terrifying details about the space immediately surrounding it. We know this not because we have sent a probe, but because we have built cathedrals of glass and silicon to capture the ghosts of its light. The human obsession with this star drove us to construct instruments of almost impossible precision. Consider the Very Large Telescope, perched in the freezing, hyper-arid desert of the Atacama in Chile. It is a facility designed to escape the distortion of our own atmosphere, staring upward with mirrors over 26 feet across. Attached to these massive eyes is an instrument called a spectrograph. It does not take photographs. Instead, it takes the microscopic trickle of light from Proxima Centauri, photons that have been traveling through the void for 4 years, and shatters that light into a spectrum, a barcode of colors. By analyzing the microscopic dark lines within this barcode, lines created by the chemical elements in the star's atmosphere, absorbing specific wavelengths of light, astronomers look for a specific anomaly. They look for the Doppler effect. You hear the Doppler effect when a siren races past you on a highway. The pitch compresses and raises as it approaches, then stretches and drops as it fades away. Light behaves exactly the same way. If a star is moving toward us, its light waves are compressed, shifting slightly toward the blue end of the spectrum. If it is moving away, the waves stretch, shifting toward the red. When we trained these highly sensitive instruments on Proxima Centauri, we did not see a stationary star. We saw a star that was breathing. It was rhythmically, microscopically swaying back and forth. The starlight was shifting blue, then red, then blue again, in a precise cycle lasting just over 11 days. The star was moving, but it was not moving fast. The numbers derived from this spectral shift are profoundly humbling. The giant churning reactor of Proxima Centauri is wobbling at a speed of roughly 3 miles per hour. That is the pace of a human being walking down a sidewalk. Let that sink into your mind. We are standing on a spinning globe, looking through an ocean of shifting atmosphere, across 25 trillion miles of absolute nothingness, and we are precisely measuring a star moving at a walking pace. The engineering required to achieve this is staggering. The spectrograph used to make this measurement is sealed inside a vacuum chamber, isolated from all seismic vibrations, and chilled to a fraction of a degree above absolute zero, just to ensure that the microscopic expansion of metal from room temperature does not corrupt the data. And the mathematics of that walking pace wobble revealed a phantom. A star does not sway on its own. It requires a gravitational anchor, an invisible partner pulling at it in a tight, frantic orbit. The wobble was the undeniable fingerprint of a planet, Proxima b. When the discovery of Proxima b was announced, the media celebrated. They called it an Earth-mass planet, residing within the star's habitable zone. The term habitable zone is one of the most dangerously misleading concepts in modern astronomy. It merely describes the mathematical orbital band around a star where the temperature is theoretically right for liquid water to exist on a rocky surface. It implies a sanctuary. It implies an alternative. But the mechanics of reality paint a much darker picture. Because Proxima Centauri is so small and cold, its habitable zone is pulled incredibly close to the star. Proxima b orbits at a distance of roughly 4 million miles. To put that in perspective, our Earth orbits the Sun at 93 million miles. Proxima b is hugging its star so tightly that its year, the time it takes to complete one full orbit, lasts only 11 terrestrial days. When a planet orbits that close to a massive gravitational body, the laws of orbital mechanics enforce a brutal condition known as tidal locking. Just as our moon is tidally locked to the Earth, forever showing us the exact same face, Proxima b is almost certainly locked in a permanent, deadly embrace with its star. Imagine the reality of standing on the surface of Proxima b. It is a world without days or nights. It is a world violently divided. On the day side, the sickly magenta sun hangs eternally paralyzed in the exact same spot in the sky. The surface is subjected to an endless, unrelenting bombardment of heat and the star's apocalyptic X-ray flares. The oceans, if they ever existed, would have been flash-boiled into the atmosphere and systematically stripped away by stellar winds long ago. It is a sun-scorched wasteland where the shadows never move. But cross the Terminator line, the narrow band of eternal twilight that divides the planet, and you step into the night side. Here, the star has never been seen. It is a realm of permanent, absolute darkness, facing the freezing void of deep space. Without a thick atmosphere to distribute the heat from the day side, the temperatures here would plunge to hundreds of degrees below zero. Any atmosphere, any water, any gas at all would freeze solid and fall to the ground as a permanent, toxic snow. It is an eternal glacier in the dark. This is the great prize. This is the destination that our terrestrial intuition so desperately wants to believe is a second home. A radiation-blasted rock locked in a permanent state of dual apocalypse. But the horror of Proxima Centauri is not merely what is waiting there. The true crushing existential terror lies in the math required to simply cross the gap. We have observed the target. We have calculated the distance. We understand the abrasive, lethal nature of the interstellar medium. The final step is to ask the engineers how we push a payload across that 25 trillion mile abyss. And it is here, in the cold, unyielding equations of propulsion and mass, that the universe reveals the absolute nature of its quarantine. To move a mass through space requires energy. To move it faster requires exponentially more energy. We look at the chemical rockets that carried us to the moon, roaring columns of fire that shake the Earth, and we feel a sense of power. But in the face of the interstellar chasm, chemical propulsion is not just inadequate, it is mathematically laughable. To understand why, we must examine a formula that dictates the absolute limits of rocketry. It is an equation that calculates the ratio between the mass of the payload you want to deliver and the mass of the fuel required to get it there. As you demand more speed, the fuel requirement does not grow in a straight, manageable line. It curves upward in a steep, exponential nightmare. If you want to push a ship to even a fraction of the speed of light using the most efficient chemical engines humanity has ever conceived, the math dictates that you would need more fuel than exists in the entire observable universe. The rocket equation is a tyrant. It states, simply and mercilessly, that every ounce of fuel you add to a ship makes the ship heavier, which in turn requires more fuel to push that newly added fuel. It is an endless, self-defeating loop. It is nature's way of locking the door. You cannot carry the energy required to cross the void, because the energy itself becomes too heavy to carry. So, we abandon chemicals. We dream of nuclear propulsion, of riding the shockwaves of atomic detonations, or harnessing the annihilation of antimatter. We theorize majestic sails catching the momentum of lasers fired from Earth, pushing gossamer probes through the dark. We stretch our engineering models to the absolute breaking point of known physics. We design hypothetical engines that harness the very fabric of reality, engines that run on fusion, engines that theoretically convert mass into pure energy with perfect efficiency. And yet, even when we simulate these godlike technologies, even when we grant ourselves the benefit of a century of unbroken, miraculous scientific advancement, the abyss smiles back, unfazed. The energy requirements remain so colossal, the engineering tolerance is so microscopically unforgiving, and the lethal hazards of the journey so severe that we are forced to confront a deeply unsettling possibility. It is not a matter of waiting for better technology. It is not a matter of simply building a bigger engine or finding a denser fuel. The barrier is written into the fundamental code of the cosmos. Let us zoom out from the violent orbit of Proxima b and look at the architecture of the void separating us. Before a probe could even dream of tasting the true interstellar medium, it must first navigate the ghostly graveyard of our own solar system, known as the Oort cloud. This is not a dense asteroid belt from a science fiction film. It is a spherical shell of icy debris, the frozen leftover shrapnel from the formation of our sun, stretching outwards for light years. The distances between objects in the Oort cloud are so vast that you could fly through it blindly for centuries and never hit a single pebble. But its mere existence highlights the grotesque scale of our isolation. Our sun's gravitational influence is so immense that it holds these frozen comets in a delicate orbit, trillions of miles away. You can travel outward at tens of thousands of miles an hour, watching the sun shrink until it is indistinguishable from any other star in the black sky, and you will still mathematically belong to the solar system. You are still inside the house. The sheer volume of space that must be traversed is a psychological weapon. Imagine a sphere of space, centered on Earth, expanding outward to encompass Proxima Centauri. Within this sphere, there are exactly two star systems, ours and the Alpha Centauri trinary system, of which Proxima is a distant orbiting member. The amount of empty volume contained within that sphere is a number so staggeringly huge that if you were to represent every cubic mile of it with a single drop of water, you would fill all the oceans of Earth billions of times over. And within that incomprehensible ocean of nothingness, there is practically zero matter. This is the scale of the mystery. It is not just that the star is far away. It is that the universe is aggressively, predominantly empty. Matter is an anomaly. The stars, the planets, the swirling galaxies, they are nothing but microscopic impurities in an otherwise flawless, infinite vacuum. We fixate on the light because our eyes are built to seek it. We look at the night sky and see a tapestry of stars, but that is an optical illusion, a trick of a brain that refuses to process the negative space. The true nature of the universe is the dark. The darkness is the rule. The light is a rounding error. And it is across this flawless infinite dark that we must attempt to throw a mechanical needle, threading it through the gravitational crosswinds of the galaxy, hoping it survives the kinetic bombardment of a million microscopic impacts, just to reach a star that is actively trying to sterilize its only planet. We measure, we calculate, we build our cathedrals of glass to watch it breathe. We understand its violent mechanics perfectly. We map its doomed frozen world. But observation is a passive act. It is safe. When we shift from observation to physical interaction, when we dare to ask how we might bridge that 25 trillion mile gap, the physics we so proudly use to map the star suddenly turns against us. The equations of energy and momentum become insurmountable blockades. The deeper we dig into the theoretical engines required to make the journey, the more the mathematics begin to resemble a locked door, and the more the universe seems to whisper that some thresholds are simply not meant to be crossed. To understand the true nature of this locked door, we must strip away the romanticism of space travel and confront the cold, unforgiving architecture of relativity. In the early 20th century, a patent clerk named Albert Einstein did not just revolutionize physics, he unwittingly drafted the exact blueprints of our cosmic prison. Before Einstein, we believed space and time were a static stage, a fixed theater where the events of the universe simply played out. We believed that if you built a machine powerful enough, you could accelerate infinitely, pushing the needle on the speedometer higher and higher until the stars blurred into lines of light. Einstein shattered this intuitive comfort. He revealed that space and time are not separate entities, but a single, interwoven fabric. And more terrifyingly, he proved that this fabric has a hard physical limit. The speed of light is not merely the speed at which photons travel. It is the maximum speed of causality. It is the absolute speed limit at which the universe allows any 2 points in reality to communicate with one another. When we try to cheat this limit, when we attempt to force mass to approach the speed of light, the mathematics of relativity do not simply resist us, they actively punish us. Imagine you are the architect of a deep space vessel. You have somehow solved the fuel crisis. You have tapped into the perfect energy source, perhaps harnessing the raw power of matter-antimatter annihilation, where physical mass is converted into pure, blinding energy with absolute efficiency. You ignite the engines. The ship begins to accelerate. At first, the physics behave exactly as your terrestrial intuition expects. You burn fuel, you gain velocity, you cross 1% of light speed, then 5, then 10. But as you push faster, tearing through the vacuum at a significant fraction of the speed of light, a catastrophic paradox begins to unfold within the fundamental properties of your ship. The mathematics governing momentum dictate a merciless trade-off. As your velocity approaches the absolute limit of the universe, the energy you pour into the engines stops translating into speed. Instead, reality forces that energy to manifest as mass. This is not an optical illusion. It is a physical law. The faster you move, the heavier your ship becomes relative to the universe around you. At 90% of the speed of light, your vessel is massively heavier than when it sat on the launch pad. To push this newly acquired mass even faster, you need exponentially more energy. By the time you reach 99% of light speed, your ship behaves as though its mass is approaching infinity. The engines are roaring with the power of a dying star, yet the speedometer barely creeps forward. To reach the absolute speed of light, the mathematics demand an infinite amount of energy to push an infinite amount of mass. The universe has constructed an asymptotic wall. You can slide closer and closer to it, but the laws of physics will mathematically forbid you from ever touching it. And as you fight this losing battle against your own accumulating mass, another, far more insidious phenomenon takes hold. Time itself begins to fracture. We are biologically wired to believe that time is a universal constant, a steady, rhythmic metronome ticking away uniformly across the entire cosmos. But relativity dictates that time is entirely subjective. It bends and stretches depending on how fast you're moving through the fabric of space. As your ship accelerates toward the speed of light, the flow of time within your vessel slows down relative to the stationary universe you left behind. For the crew aboard this hypothetical ship, time seems to pass normally. A second is a second. A heartbeat is a heartbeat. But look out the window, back toward the solar system you departed, and the horror of time dilation reveals itself. For every day you experience on the ship at these extreme velocities, years, decades, or even centuries might evaporate on Earth. You are no longer just traveling through space. You are inadvertently traveling through time. This is the ultimate, heartbreaking paradox of interstellar travel. Even if you could build a ship capable of surviving the kinetic bombardment of the void, even if you could harness the energy of a star to push it to a fraction of light speed, by the time you reach Proxima Centauri, investigate its barren, radiation-scorched planets, and return home with your findings, The world you fought so hard to report back to will be gone. The engineers who built your ship will be dust. The civilizations that funded your journey may have collapsed. The very language you speak might be a dead tongue. You have conquered the physical distance, but the universe has exacted a toll in time. You become a ghost, returning to a future that has no memory of your departure. But perhaps you are stubborn. Perhaps the survival of the species is at stake, and you are willing to sacrifice your connection to the present to reach the stars. You decide to ignore relativity and look for a loophole. If pushing through space-time is too costly, too slow, and too destructive, then the only logical solution is to cheat. You must bypass the fabric of space entirely. This is where theoretical physics descends into madness. We turn to the equations of general relativity, the complex tensor calculus that describes gravity not as a force, but as the curving and warping of space-time around massive objects. In the late 20th century, a physicist named Miguel Alcubierre looked at these equations and discovered a mathematical quirk. The math permitted a theoretical anomaly, a warp drive. The concept is seductively simple. Instead of moving a ship through space, you move the space around the ship. You engineer a machine that intensely compresses the fabric of space-time in front of the vessel, while simultaneously expanding it behind the vessel. The ship itself sits inside a localized bubble of flat, unwarped space. It does not move. It experiences no acceleration, no crushing g-forces, and no time dilation. It is the bubble of space that moves, surfing on a wave of altered reality across the cosmic ocean, potentially traveling faster than the speed of light, without ever breaking the local speed limit within the bubble. On paper, it is the perfect escape route. It is the holy grail of interstellar ambition. But when you ask the mathematics what is required to physically construct this architecture, the equations demand the impossible. To compress the fabric of reality in front of the ship requires an immense concentration of mass and energy, akin to a black hole. We theoretically understand how to generate positive gravity, but to expand the space behind the ship, to create the crest of the wave pushing you forward, the math dictates the absolute necessity of something called negative energy, or negative mass. Try to visualize negative mass. It is not antimatter, which has normal positive mass but an opposite electrical charge. Negative mass is a substance that breaks the fundamental symmetry of our universe. If you push an object with positive mass, it accelerates away from you. If you were to push an object with negative mass, it would accelerate backward toward your hand. If you drop it on Earth, it would not fall. It would fall upward, repelled by the gravity of our planet. It is a phantom material. It is a mathematical placeholder, a minus sign inserted into complex equations to make the geometry work. In all our observations of the cosmos, in all our particle accelerators, smashing the fundamental building blocks of reality together, we have never found a single solitary shred of evidence that negative mass exists. The mathematics of the warp drive are pristine, but they require a material that the universe seemingly refuses to manufacture. It is like having a perfect, flawless blueprint for a perpetual motion machine, with the only caveat being that it requires you to build it out of a color that has never existed. And even if, by some miraculous manipulation of quantum mechanics, we could synthesize microscopic amounts of this negative energy, the sheer scale of the requirement is apocalyptic. Early calculations for the Alcubierre drive suggested that to propel a small passenger ship to the closest star, you would need to convert an amount of mass equal to the entire planet Jupiter into pure, raw energy. We struggle to harness the energy of a few splitting atoms. The universe demands we consume entire gas giants just to turn the key in the ignition. So, the loopholes close. The exotic theories collapse under the weight of their own impossible demands. We are forced back into the slow, grueling reality of the sublight void. And it is here, in the physical, biological reality of the long journey, that the final, most terrifying barrier is erected. Let us assume we build the perfect sublight generation ship, a massive, self-sustaining ecosystem encapsulated in a titanium shell, a vessel designed not for a single crew, but for a lineage. The people who arrive at Proxima Centauri will be the great-grandchildren of those who launched. We have solved the propulsion. We have solved the fuel. But we have fundamentally ignored the environment we are sailing through. Space is not a benign emptiness. It is a hostile, radioactive shooting gallery. Our planet protects us with a massive magnetic field, an invisible shield that deflects the worst of the cosmic weather. But once a ship leaves the protective cocoon of the solar system, it is exposed to the raw, unfiltered fury of the galaxy. The primary threat is not from crashing into asteroids, it is from galactic cosmic rays. These are not rays in the sense of light, they are the atomic nuclei of heavy elements, iron, nickel, carbon, that have been stripped of their electrons and accelerated to nearly the speed of light by the violent shock waves of exploding stars thousands of light years away. They are microscopic bullets carrying kinetic energy so immense that a single particle can pack the punch of a pitched baseball. When these relativistic heavy ions strike the hull of a spacecraft, they do not bounce off. They shatter the atoms of the shielding, creating a secondary shower of lethal radiation, neutrons, protons, and gamma rays, that floods the interior of the vessel. The thicker you make the shielding, the more material there is for the cosmic rays to interact with, sometimes making the secondary radiation worse. It is an engineering nightmare with no obvious solution. But the true horror lies in what these particles do to biological tissue. When a high-energy iron nucleus tears through a human body, it leaves a microscopic trail of devastation. It physically shears through the double helix of DNA. Our cells have evolved to repair minor DNA damage caused by background radiation on Earth. But the complex, clustered damage inflicted by a heavy cosmic ray is entirely alien to our biology. The cells cannot repair it. They either mutate, rapidly accelerating the onset of aggressive cancers, or they undergo programmed cell death. In a generation ship traveling for centuries, the continuous low-dose bombardment of cosmic rays would slowly dismantle the crew from the inside out. It would degrade their central nervous systems, leading to severe cognitive decline. It would induce cataracts, destroying their vision. It would cripple their cardiovascular systems. The children born in the deep void would inherit a heavily irradiated, mutating genetic code. Before the ship even crossed the halfway mark, the crew would likely be a decaying, cognitively impaired shadow of humanity, entirely incapable of operating the complex machinery required to navigate the vessel. We build machines of silicon and metal because they are tougher than flesh. But the void is merciless even to our technology. Those same cosmic rays that shred human DNA also wreak havoc on microprocessors. A high-energy particle striking a computer chip can flip a microscopic switch from a 1 to a 0, causing a phenomenon known as a single-event upset. In an autonomous ship relying on millions of lines of code to manage life support, navigation, and propulsion over thousands of years, these constant random errors will accumulate. The systems will degrade. The artificial intelligence will develop digital dementia. The ship will slowly go insane in the dark. We are faced with a compounding wall of impossibilities. The physics of propulsion require infinite energy. The mechanics of time erase our connection to our home. The exotic theories demand materials that do not exist. And the physical environment of the void actively seeks to dismantle the biological and technological architecture of the traveler. We look at Proxima Centauri, our closest neighbor, and we realize the bitter truth of our existence. The universe did not design the distance between stars to be traversed. The laws of thermodynamics, the speed of light, the lethal radiation of the interstellar medium, they are not engineering challenges waiting to be solved. They are the immutable laws of quarantine. They are the walls of a cell. We are forced to confront the chilling possibility that we are marooned. The stars will forever remain beautiful, distant points of light, taunting us with an intimacy that is mathematically prohibited. And as we stare into that insurmountable abyss, as the realization of our absolute isolation sets in, a new, far darker question emerges from the silence. If we strip away the comforting mythology of human expansion and accept the mathematical reality of this cosmic quarantine, the implications ripple backward, destroying our most deeply held assumptions about the future of our species. For over a century, our cultural consciousness has been saturated with the concept of a manifest destiny among the stars. We have treated the galaxy as a map of future real estate, assuming that our trajectory from the caves to the oceans to the moon was a straight line pointing inevitably toward Alpha Centauri, the Orion Cygnus arm, and beyond. We have built an entire philosophical framework around the idea that Earth is merely our cradle. But a cradle implies a temporary residence, a place you outgrow and leave behind. The relentless mechanics of the void, the insurmountable energy requirements of the rocket equation, and the catastrophic biological toll of deep space travel paint a fundamentally different picture. Earth is not our cradle. It is our permanent, non-negotiable residence. It is the only theater in which the entire arc of human history will be permitted to play out. This realization forces a profound and terrifying recontextualization of the greatest mystery in modern astronomy, the Fermi paradox. When we look up at a galaxy containing hundreds of billions of stars, surrounded by an observable universe containing hundreds of billions of galaxies, the mathematics of probability suggest that the cosmos should be teeming with life. Even if the genesis of biology is an incredibly rare accident, the sheer volume of evolutionary laboratories available guarantees that complex, intelligent civilizations must have arisen countless times. Yet, when we tune our massive radio telescopes to listen to the void, searching for the chatter of a galactic empire, we hear nothing. Only the cold, dead static of the cosmic microwave background. For decades, astrophysicists and philosophers have panicked over this silence. They have invented terrifying theoretical concepts to explain it, most notably the Great Filter, the idea that some unknown, unavoidable catastrophe inevitably wipes out advanced civilizations before they can colonize the stars. We have searched for this filter in the mechanics of nuclear war, in the runaway effects of climate collapse, in the creation of hostile artificial superintelligence. We have looked for the weapon that kills species before they can become interstellar. But the brutal architecture of the distance between stars offers a far more chilling, entirely mundane solution to the paradox. There is no mysterious, impending apocalypse required to keep the galaxy quiet. The Great Filter is not a weapon, nor a behavioral flaw in intelligent life. The Great Filter is space itself. It is the inescapable, grinding reality of relativity and thermodynamics. Imagine a galaxy overflowing with intelligent life. Thousands of vibrant technological species, all looking up at their respective night skies, all feeling that same ancestral urge to reach out and touch the lights. They master fire, they split the atom, they launch their first primitive probes into their local orbits. But the moment they set their sights on the neighboring star, they collide head-on with the exact same asymptotic wall of physics that we have. They run the calculations for sublight propulsion and watch the fuel requirements expand to consume their entire planetary mass. They theorize exotic warp metrics, only to find that the universe refuses to provide the negative energy required to bend the geometry of space-time. They are not dead. They are simply trapped. The universe is not an empty graveyard. It is an infinite archipelago of solitary confinement cells. Each civilization is a flickering campfire in a dark, boundless forest. They can see the distant glow of other fires through their telescopes, separated by thousands of light years. But the temperature of the forest is absolute zero, and the distance between the fires is so unimaginably vast that any attempt to walk from one to another guarantees freezing to death in the dark. And so the silence of the night sky is not the absence of life. It is the acoustic consequence of the quarantine. Even if another civilization attempted to scream into the void, using the most powerful electromagnetic transmitters imaginable, the laws of physics degrade the message. The inverse square law dictates that as a radio wave expands outward in a sphere, its energy dilutes exponentially. By the time a signal from a distant civilization reaches our solar system, it has been stretched, distorted, and weakened so profoundly that it is entirely indistinguishable from the background radiation of dead stars and primordial dust. We cannot physically reach them, and we cannot acoustically hear them. The quarantine is absolute, enforced on both a kinetic and an electromagnetic level. If we are forced to accept that we are marooned here, a permanent fixture of this specific solar system, we must confront the long-term forecast of our local environment. The comforting illusion of interstellar colonization has always served as a psychological escape hatch. Whenever we contemplate the eventual, unavoidable death of our planet, we soothe ourselves with the promise that our descendants will have long since evacuated. We imagine them watching the destruction of Earth from the safety of a terraformed exoplanet, a tragic but survivable chapter in the history of a multi-stellar species. Without that escape hatch, the mechanics of deep time become a claustrophobic nightmare, because we cannot outrun the life cycle of our host star. Our sun is a massive, unfeeling nuclear furnace, fusing hundreds of millions of tons of hydrogen into helium every single second. It is currently in the stable, middle-aged phase of its life, a period known as the main sequence. But stellar evolution is a one-way thermodynamic street. As the sun burns through its hydrogen core, the physics of its internal pressure begin to shift. To maintain the delicate balance against the crushing weight of its own gravity, the core must burn hotter and faster. This is not a sudden, explosive event, but a slow, methodical strangulation. Every 100 million years, the sun's luminosity increases by roughly 1%. On a human timescale, this is imperceptible, but on the geological timescale of a quarantined species, it is a ticking clock counting down to planetary sterilization. In roughly 1 billion years, a fraction of the Earth's total lifespan, the increased solar radiation will push the temperature of our planet past a critical thermodynamic threshold. The complex silicate weathering cycle, the geological thermostat that regulates carbon dioxide and keeps our atmosphere breathable, will permanently break down. Plant life, the foundation of the entire biological food web, will asphyxiate and die. As the surface temperature climbs, the oceans will begin to rapidly evaporate, pumping trillions of tons of water vapor into the atmosphere. Water vapor is a potent greenhouse gas. This triggers a runaway feedback loop, a brutal cycle of accelerating heat that cannot be stopped or reversed by any level of human engineering. The oceans will literally boil away into space, leaving behind a scorched, barren wasteland of baked rock and salt. Earth will become a twin of Venus, suffocating under a thick, toxic atmosphere with surface temperatures hot enough to melt lead. If we are trapped in the solar system, this is the unavoidable horizon of our existence. We are locked inside a vault with a slow-burning incendiary device. We can burrow underground. We can attempt to build orbital habitats. We can flee outward to the frozen moons of Jupiter or Saturn, chasing the shifting habitable zone as the sun expands. But these are temporary delays, desperate maneuvers within a shrinking cage. Eventually, the sun will exhaust its hydrogen entirely. The core will collapse, and the outer layers of the star will violently expand outward, transforming our once nurturing sun into a monstrous red giant. Its atmosphere will swell to engulf the orbits of Mercury, Venus, and ultimately, the Earth. The physical rock upon which every human being was born, where every war was fought, where every line of code was written and every telescope was built, will be vaporized, completely subsumed into the superheated plasma of our dying star. If interstellar travel is a mathematical impossibility, then this event marks the absolute erasure of our physical record. There will be no museum of Earth on some distant alien world. There will be no surviving archives. The quarantine ensures that the universe will scrub the site of our existence clean, leaving absolutely zero trace that a species capable of mapping the cosmos ever stood here. This realization shatters our fundamental understanding of reality itself. We are conditioned to think of the universe as a singular, connected entity, a grand tapestry in which we are playing a small but integrated part. We imagine that there is a universal now, a synchronized present moment shared by every star and every planet in the void. But the impossibility of travel and the paralyzing delay of light-speed communication fracture this illusion. Reality is not a unified tapestry. It is a scattered collection of isolated islands, forever out of sync with one another. When we point our telescopes at Proxima Centauri, we are not looking at the star as it exists in our present moment. We are watching a ghost, an image from over 4 years ago. If we look at a star 1,000 light years away, we are peering into the deep past, watching events that concluded before the fall of the Roman Empire. Because information cannot travel faster than light, and because physical matter is forbidden from crossing the void without catastrophic consequences, the concept of a shared galactic reality is a physical impossibility. Every star system is locked in its own isolated timeline, completely severed from the present moment of everything else in existence. We are not participating in the universe. We are merely receiving its delayed, fragmented echoes. We are a species sitting in a dark room, watching a delayed broadcast of a play we can never attend, featuring actors who may have died millions of years ago. The cosmos is not a place we can conquer. It is a graveyard of isolated realities, permanently separated by an ocean of dark, silent geometry. And as the full weight of this localized existence settles into our consciousness, as we realize that the horizon of our world is not the beginning of a grand journey, but the final, absolute boundary of our reach. When you walk outside tonight and look up at the scattered ancient dust of the Milky Way, you are not looking at a frontier. You are looking at the walls of a cell. For generations, we have wrapped ourselves in the comforting mythology that the universe is a grand puzzle waiting to be solved, an ocean waiting to be crossed. We named the stars, charted their mechanical movements, and convinced ourselves that because we possess the intellect to understand the cosmos, we are somehow entitled to inherit it. But the cosmos does not care about our intellect. It does not recognize our ambition. The sheer crushing scale of the void is a mathematical executioner, indifferent to our survival and entirely immune to our engineering. The distance to Proxima Centauri is not an obstacle to be overcome. It is an absolute thermodynamic quarantine. It is the universe enforcing a permanent state of solitary confinement upon a species that is only just beginning to realize the locks cannot be picked. We look at the light of these distant suns, measuring their microscopic wobbles with godlike precision, but this knowledge grants us no power. It is a profoundly cruel paradox. The deeper our understanding of physics becomes, the more perfectly we understand the exact mechanisms of our own imprisonment. We map the prison bars down to the subatomic level, calculating the tensile strength of space-time itself, only to confirm that the cage is unbreakable. Every telescope we build, every deep space probe we hurl into the dark, acts as a mirror reflecting our own isolation back at us. We are the ultimate tragic observers, cursed with a consciousness vast enough to comprehend the infinite, yet trapped within biological machines that are permanently tethered to a microscopic grain of silicate and iron. We will not spread across the stars. There will be no galactic federation, no grand human empire spanning the Orion Arm. The story of humanity is entirely brutally localized. Every triumph, every atrocity, every scientific breakthrough, and every piece of art we have ever created will be permanently contained within the gravitational well of this single, unremarkable yellow dwarf star. The illusion of a shared cosmic destiny is just the final, desperate coping mechanism of a brain wired to fear the dark. We scream radio waves into a void that simply absorbs the energy, scattering our grandest declarations of existence into meaningless background noise before they even cross the boundary of our own frozen perimeter. And eventually, as the cold physics of our sun dictate, even this brief, noisy chemical anomaly will be sterilized. The oceans will boil away, the atmosphere will violently ignite, and the physical evidence that we were ever here will be permanently scrubbed from the cosmic record. The Earth will be swallowed by the expanding plasma of a dying star, and the silent equilibrium of the solar system will be restored, flawless and uninterrupted. Look at the closest star tonight. Let the reality of that 25 trillion mile abyss strip away the arrogant ego of our species. The light hitting your eyes is not a beacon calling us forward into the dark. It is the cold, silent glow of a fire we can never reach, burning in an empty forest where we are destined to remain forever alone.